students, I am going to discuss the conservation of linear momentum today. What is the meaning of conservation? Conservation means to maintain as it is. Conserve something, conserve the energy means there is no change in the energy. The conservation of linear momentum, momentum remains constant. So under what condition this situation prevails, that we will look at. Okay. So we have studied in Newton's second law that when net external forces acting on the system of particles causes rate of change of momentum. So we know this, that F net on the system of particles is equal to the rate of change of momentum. It is the vector quantity, direction is the direction of force, and P is where P. What is this? It is the linear momentum. Momentum of the system. And F net, when we talk, F net means total force acting on the system. That is external, net external force acting on the system. Even though system is made of number of particles, so particles may be interacting, individual particles of the system may be interacting, and there will be internal force between these particles. And one thing we know, that in a system, when there is internal forces due to interaction with the particles, they neutralize each other, right? And net internal forces acting in the system is zero. So here when we talk about F net, we are talking about net external forces acting on the system. When we talk about system, that is system of particles. System of particles or masses, I can say. System of particles or system of masses. So F net is equal to dP upon dt. See, if somewhere or other this F net is zero, net external force is zero, then what will happen in that case? If the system, a net force, when net force is zero, then we say that system is isolated from the external forces. So when if the system is isolated, then F net, that will be equal to 0. F net is 0, and F net, that is this is external forces acting on the system, net external forces. In that case, when F net is 0, means rate of change of momentum is 0. Therefore, dP upon dt, that is equal to 0. Right? And derivative of momentum is 0. This momentum has to be constant. Or you can say change in momentum is 0. Change in momentum is 0 means momentum is constant. Therefore, this implies P is equal to constant. It is the important, and this is the law. Conservation of linear momentum means linear momentum is constant. What is the condition? That is net external force acting on the system of particles must be equal to 0. Right? No doubt, there will be individual particles are there. The individual particles may be having momentum, but vector sum of all these momenta of individual particles of the system will be equal to 0. Right? Here one more important thing I will tell you, when we talk about F net. So F net means external forces. So in the center of mass, as I have told, if individual masses are there, so instead of taking all these masses to study the force, studying the velocities, studying the acceleration of these particles, we study all these physical parameters or physical quantities of center of mass. So F net deals with the velocity acceleration of center of mass. Even though particles may be having velocities, or in short it is momentum, but vector sum of all these momenta of individual particles of the system will be equal to 0, and this is it means momentum is conserved. Momentum is conserved means internal forces do not cause any kind of change in velocity in center of mass. Internal forces may cause change in velocity and acceleration of individual particles of the system, but the velocity and acceleration of center of mass will not be affected by the internal forces, and external forces are 0. So external forces affect the center of mass. Velocity changes, right? Means there will be acceleration due to external forces if it is not 0, right? So this is the condition. Conservation of momentum is constant in this case. So this can be understood by Newton's third law. I will say that when two masses collide, when there is no external forces, they are colliding due to interaction in these masses. So first of all, we will take the system of two masses which are moving with certain velocities, and there is no external force. When they collide, then there is some force on these individual masses. That is action-reaction pair according to Newton's third law. So I will tell you what the Newton's third law is. That is Newton's third law. When there is interaction between the bodies, interaction means if two bodies are there, there will be force. That is means one body will be applying force on the other, and this body applying force on the other. That is called the interaction between the two bodies. And due to these forces, and these forces will be equal and opposite, right? Newton's law third law tells then when there is interaction between the body, then for every action there is equal and opposite reaction, and action and reaction act on two different bodies, right? So it is for every action there is equal and opposite reaction, and action and reaction act on two different bodies. What is the significance of this? I'll let you know. Suppose there are two masses. This is A and this is B, or we may say 1 and 2 also. One force is acting on this. So what is the action-reaction pair? One force is acting on this, on A. Then since these surfaces are in contact, there is a contact force. So A will apply some force on B. So that force will be called FB by A. A is applying force on B, and simultaneously B applies force on A. This is called FAB. This is called action-reaction pair. We can say this action and this reaction, or this action, this reaction, either way. These two forces are there, two different names are to be given. That is, one is action and another is reaction. So action is on B, then reaction will be on A. When action is on A, reaction will be on B. But these two forces will be equal in magnitude and opposite in direction. So in the vector form, if you write, so these are the vectors, right? So by magnitude, both are equal. So I will write FAB is equal to FBA. I have written by magnitude. By magnitude, both are equal. But in the vector form, if you write, so both are opposite to each other. So FAB is equal to minus FBA. If you are taking the magnitude of this, both will be equal, right? So by magnitude, that is mod of FAB is equal to mod of minus FBA, this vector, and FAB is equal to FBA, or by magnitude, if I write FAB is equal to FBA. I am not putting the arrow, right? So this is by magnitude and this is by vector form. So these are for action reaction I have shown. For action reaction, even though I have applied external forces, but I am talking over here about action reaction pair, which are magnitude, by magnitude they are equal and direction is opposite. So this can be proved by collision of two objects. When two objects are moving with certain velocities and they collide, because when they are moving with certain velocity, there is no net external force acting on it. Newton's second law tells that there will not be change in velocity. There won't be acceleration. Because we know F net is equal to m into A, right? F net, that is external, that is mass into acceleration. The acceleration is rate of change of velocity. There won't be any change in velocity until there is some external, net external force applied on that object, isn't it? So if two objects are moving with certain velocities, so velocities with constant velocity they are moving, means there is no external force acting on these masses. If they collide, so due to collision, there is action reaction pair is getting formed. On the basis of that, we can show that momentum of the system before collision and after collision, and during collision, that will be the stage. So during the whole process, there will be momentum which is conserved. During the whole process of motion and collision and separation, momentum remains conserved, and that can be proved by system of two particles. See, I have considered this situation when two masses are there, A and B. A is moving in this direction, B is also moving in the same direction. I have considered the linear motion, the simplest one. With this I will prove, but this is applicable for all kinds of motion. Conservation of momentum is true for all kinds of motion, but for simplest example I have taken, with that things will be clear to you. So both are moving in the same direction, and condition is this: u1 is greater than u2. Velocity of this is less than this, so that collision will take place. If this velocity is more, so it will never collide, isn't it? So now both are moving in the same direction. After some time, A hits B. At that time, what is the situation? Then after collision, they start moving with different velocities, that is v1 and v2 in the same direction, and it may be in opposite direction also. So here I have considered they are moving in the same direction, isn't it? So in this situation, if I look at, and this system of two masses is isolated, there is no external force acting on it. This is important. They are moving with certain constant velocity, they are colliding, and they are getting separated, and they are moving different velocities. So if I look at, there is no external force, the initial momentum before collision, what is the momentum of the system? Therefore we can write the momentum of the system before collision, suppose, before collision. So this I will consider as, suppose, initial momentum, Pi. Initial momentum is momentum of this plus, because we are considering this as system. This as system. This is a boundary. There is no external force acting. This is a system. So initial momentum of the system is momentum of this plus momentum of this. So I will write that is m1 u1 plus m2 u2. That is initial momentum. Sum of the momenta of these two objects. Right? And after collision, that is that one. So momentum of the system after collision, that is, I will say PF, that is final. PF means final, I means initial, that is M1 V1 plus M2 V2. And momentum is a vector quantity, velocities are the vector quantities. Now, we will look at the situation when they are colliding. At the time of collision, when they are interacting, so naturally, as per Newton's third law, since they are interacting, there will be an action-reaction pair, isn't it? And that collision will be for a very short time. That collision will be of very short time. So see, here, action-reaction, B is exerting on some force, that is FAB, and A is exerting force on B, that is FBA. And according to Newton's third law, these forces must be equal. So we will write during collision. Three situations I have taken: before collision, after collision, and during collision what is happening. That is according to Newton's third law. According to Newton's third law, FAB is equal to minus FBA. I have written vector form. And the collision is for a very short time, right? And the duration of collision is equal to delta t. Delta t means a very short time, right? That is short duration, I will write short duration. And one thing we know, that I have already told in the previous videos, if you look at, if the force acts for a very short time, so that duration cannot be measured, right? So in that case, we take another physical quantity that is called impulse, right? Therefore, impulse is equal to FAB into delta t. This is the impulse acting on this, and impulse on A, and impulse on B is equal to FBA into delta t. Now, since FAB is equal to minus FBA, these quantities must be equal, right? Therefore, it is suppose it is 1. Therefore, from 1, FAB into delta t is equal to minus FBA into delta t. The impulses will also be equal. So what is this? These are the impulses. Impulses are equal to momentum, change in momentum, right? See, before that I had told you F net is equal to dp upon dt. This implies F net into dt, that is equal to dp. That is, change in momentum is F net into dt. Same thing is here. F net, net forces acting on this is, that is internal forces, right? Due to interaction. So this force into this duration. This is the impulse, and this is equal to change in momentum, right? So we will see the change in momentum now. FAB, the force acting on this. So FAB to delta T means change in momentum of A. The change in momentum of A is, final momentum of A is M1 V1 minus M1 U1. That is the momentum of this same object here. The final after collision, this is before collision. So there is change in momentum is equal to negative of change in momentum of B. That is M2 V2 minus M2 U2. That is change in momentum of B, and this is change in momentum of A. This implies change in momentum of A. This implies change in momentum of B. So just we will simplify. Therefore, M1 V1 minus M1 U1 is equal to minus M2 V2 plus M2 U2. Further simplification. Therefore, this is V1. That is V1. That is M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2. Then what is this? This is PF, and all are vectors, so we will use the vector sign, right? These are the vector quantities, velocities. So the vector sign over here. So PF is equal to PI. So finally we got that final momentum of this system. PF is, this is M1 V1 is plus M2 V2. This is the final momentum of the system. Both the particles. This is the system here. So, and this is the initial momentum of the system. So what did we find? In the simple example of collision of two objects, we have found that the initial momentum is equal to final momentum of the system when external force is zero. That is important, right? So we will solve a few problems, so things will be more clear to you. बहुत important question, जैसे कि भाई system जो आप particles जैसे हम बताते हैं system. Suppose gun and bullet. It is very important problems, and such problems are very generally it is being given. एक gun है, इसमें bullet fire किया जाता है. Suppose this is bullet, and this is gun, and mass is m. Its mass is m, right? Initially, when bullet was inside, right, then it was at rest. When it is fired, its velocity is u and its velocity is v. Naturally, when it was inside, bullet was inside the gun and gun was at rest. The initial, and we will consider gun and bullet as a system, right? So initial momentum of the system, initial momentum of the system means gun plus bullet. This is a system. The initial momentum of the system was 0 because bullet was inside the gun. The moment it is fired, right, firing the bullet, the momentum of the system will be what? That is the momentum of the bullet, that is mu, plus the momentum of the gun, that is mv. Isn't it? System was, bullet was inside, it was at rest. The initial momentum of bullet and gun as a system was 0. When bullet was fired, at that time the velocity of bullet is u, velocity of gun is v, right? And then the final momentum of the system is this. So as per conservation of momentum of the system, initial momentum is this, final momentum is this. Therefore mu plus m is equal to 0. Initial momentum is equal to final momentum. Therefore mu is equal to minus mv. Therefore v is equal to minus m by mu. Means when the bullet is fired, right, with velocity u and whose mass is m, then gun will go back. This minus velocity of gun is negative of the, because it is scalar quantity m by m, and this is the direction of, these are the vectors. I am talking about momentum, and momentum is a vector quantity. So velocity of the gun is then opposite to the direction of the velocity of the bullet. Minus sign tells this direction is opposite. So this is very important concept. So I will solve one problem related to this. Suppose the mass of the bullet, question, mass of the bullet is suppose 40 grams and mass of the gun is equal to 10 kg, right? And the velocity of bullet is u is equal to, this is the velocity of bullet, it is the mass of bullet, this is mass of gun, velocity of bullet is equal to suppose 200 meters per second. Then what is the velocity of gun? This you have to find. Either use formula and by magnitude. Magnitude if you are looking at. So one thing is clear. If bullet is fired in this direction, gun will go in reverse direction. So I will talk about the magnitudes only now. So initial momentum solution, right? Initial momentum is 0. So initial momentum of the system, that is, what is system? Gun plus bullet is equal to 0. And final momentum I will talk about. Final momentum is equal to how much? mb ub plus mg vg, right? And these two will be equal. Therefore mb ub plus mg vg, that is equal to 0. Put the values. mb is 40 gram. Therefore 40 into 10 to the power minus 3, it is gram. So we'll make it in kg. That is ub is 200 plus mg is 10 kg into vg is equal to 0. So here we will find the value of vg. So how much it is? 8, because 1 2 3 this will go. So that will be 4 into 2 8 plus 10 vg, that is equal to 0. Therefore vg is equal to how much? Minus 8 by 10, that is equal to minus 0.8 meters per second. Minus 0.8 meters per second means gun will be going reverse direction. So the direction of velocity of gun is the opposite to the direction of velocity of the bullet. So this is the conclusion. Therefore, by magnitude, Vg is equal to 0.8 meters per second. With this velocity, gun will be going behind. So this way, there is one example. Number of examples I will do later. So इसमें बहुत से questions हम solve करेंगे. हम फिर मिलेंगे. And till then, all the best. Take care of you. Remain fit and healthy.